Hi everyone, I'm Wu. Today's topic is why should we be cautious when using coaxiality? Let's take a look at the functional condition. Here we have two coaxial holes with different sizes, and a shaft needs to pass through them. To ensure that the shaft can pass smoothly through the two holes in the base, how should we control the relevant features of the base and the shaft? As we discussed in other videos, for these two hinge holes, we can directly use the common datum and use coaxiality to control the two holes individually. For the shaft, we use the same approach, using a common datum A-B with coaxiality to control it. Once we apply a common datum, this becomes the common datum A-B. Here we have two tolerance zones. Since each tolerance zone is theoretically coaxial with datum axis, the tolerance zones are also theoretically coaxial with each other. The same principle applies to the shaft as well. What I want to emphasize here is that once a common datum is applied, the coaxial relationship between the tolerance zones is guaranteed. So, for a shaft, when we want to control coaxiality, such as between the bearing seats at both ends, using a common datum A-B together with coaxiality is the most common specification method, as shown in this example. Some of engineers asked me, what if we take the left shoulder as the datum and use coaxiality to control the right shoulder, as shown here? Would this specification be acceptable? My answer is this type of specification is too restrictive from a manufacturing standpoint, and it is very difficult for supplier to meet. Why is that? Let's take a closer look. Let's make a comparison. First, let's look at the requirement when coaxiality is specified using a common datum. This is the actual part, slightly exaggerated for illustration. These two inclined lines represent measured feature for coaxiality. This is the common datum A-B, and these are two tolerance zones with a diameter of 0.03. At this point, two lines that is the measured feature just fall within the tolerance zone, so they meet the coaxiality requirement. That's the case with the common datum. What if we switch to a different way of specifying it? What if we use one end as a datum and apply coaxiality to control other end? At this point, this inclined line becomes datum A, and the inclined line on the right is the measured feature. The evaluation of coaxiality is based on how much the measured feature deviates from datum A. Based on the precision minimum zone method, we first extend datum A, then identify the point of maximum deviation on the measured feature, and then construct a cylinder about datum A to envelop this point. The diameter d of this cylinder is the coaxiality error of the measured feature relative to datum A. As you can see, this value can be quite large. Why does this happen? Even if the two cylinders are machined together in the same setup, if the axis at the datum end shifts even slightly, once that axis is extended, the distance to the measured feature can change significantly. Take a moment to really think about this effect. As saying goes, a tiny deviation can lead to a huge error. Essentially, this is the lever effect. and the root cause of this lever effect is that time span. Of course, what we just discussed was from a manufacturing perspective, comparing coaxiality using a common datum versus a single datum. However, this should not be the final basis for design specification. The designer's decision must be based on function, meaning the design requirements must match the functional requirements. Using a common datum A-B emphasizes that both sides have equal constraint functions, and in a hinge mechanism like this, both sides typically have the same fit, which means the functional requirements on both sides are identical. Therefore, using common datum is correct specification method. It satisfies the functional requirements and is also manufacturing friendly. Whereas using a single datum does not match the functional requirements and is also unfriendly to manufacturing. It is an incorrect specification. Does that make sense? Finally, here is a question for you. Is there a case where the structure is similar, but a single datum must be used with coaxiality applied to control the other side? Feel free to leave your thoughts in the comments.